Welcome to clickmeproject.com. Let's discuss the project about a novel medical image compression using Ripplet transform. In this paper, a novel Ripplet-based compression method for medical images is presented. The main focuses of the proposed method is to provide high-quality compressed images by presenting images at different scales and directions and to achieve high compression ratio. The novelty of this method is that it uses Ripplet transform with anisotropy capability to represent singularities along arbitrarily shaped curves and combines with a spit encoder to improve the compression performance. In this paper, they are using the spit encoder. Here we are applying Huffman encoder to improve the compression performance as well as spit. This is a flow of our process. First we load our input image, then pre-processing is done in the input image. Here we are applying median filter to removing the noises, and then we will pass through wavelet transform. We have to apply DWT to our input image. Discrete wavelet transform present on image as a sum of wavelet functions with differentiate location and scales. Then any decomposition of an image into wavelets involves a pair of waveforms, one to represent the high frequency corresponding to the detailed parts of an image and one for the low frequencies or smooth parts of an image. DWT is a multi-resolution decomposition scheme for input signals. The original signals are first decomposed in two spaces: low frequency low pass subband and high frequency high pass subband. Then we will go for a Ripplet transform. Ripplet transform on low frequency. We will applying in Ripplet. We are having three types of works in that: smooth partitioning, renormalization and Ripplet domain. For smooth partitioning, dissect the high frequency band into small partitions by defining a grid of dyadic square, and then we will apply renormalization. Each resulting dyadic square by centralized each square to the unit square 0,1 start 0,1, and then we will go for Ripplet domain, analyze each square in the Ripplet domain, and then we will apply Huffman encoding. In the base paper they are using spit encoding. Here we are using Huffman encoding. Huffman encoding is to find a way to compress the storage of data using variable length codes. Then we will get the compressed image. Now let us see the execution of the process. First we select main.m file and click run file. This is a MATLAB guide window designed for a novel medical image compression using Ripplet transform. First we load our input image. These are the data set used in our process. You can select any one of these images. Now I select this image. Then we will applying pre-processing step. In the pre-processing step, here we are applying median filter to removing the noises from the input image. Then we will applying the wavelet transformation. For applying the wavelet transformation, we are getting the four coefficients: approximate, horizontal, vertical and diagonal coefficients are displayed here. Then we will go for our Ripplet transform. In our Ripplet transform, there are three methods we are done in the Ripplet transform: smooth partitioning, renormalization and Ripplet domain. First we will applying our smooth partitioning. In the smooth partitioning, dissect the high frequency bands into the small partitions by defining a grid of dyadic square, and then we will have applying renormalization. Each resulting dyadic square by centralized each square to the unit square, and then we will go for our Ripplet domain. This is the Ripplet domain. Analyze each square in the Ripplet domain. Then we will go for our Huffman encoding. The encoded bits are displayed here. Then we will apply decoding step. The decoded image is applied. After the decoding process, we will go for our inverse DWT process, then we will get our compressed image. This is our compressed image. Then the novel Ripplet based compress method for medical images is done here. The main focus of the proposed method is to provide high quality compressed image by representing images at different scales and directions and to achieve high compression ratio. Experimental results demonstrate that besides providing high PSNR and high directionality. Thank you.